No one told you the speed of light can be exceeded. How is that possible? It is possible because even light gets tired and slows down. For example, when it enters water, not only does the water change its direction, but its speed also slows by a factor of 1.3. In fact, in specially constructed materials, light slows down even more. In 1999, using a sodium gas cooled close to absolute zero, researchers slowed light down in that gas to just 60 kilometers per hour. You could have overtaken it with a car. In 2003, using a similar gas, they slowed light down to 1.5 kilometers per hour. Now you could have overtaken it even if you were walking. And in 2013, they made light stand still for a second and a half. So the speed of light can be surpassed, but only if light is traveling through materials. In a vacuum, it's impossible. It would violate physics. And we don't want to upset Einstein. Did you know that? Astronomers have photographed the earliest galaxy we've ever seen. This is it. Meet Jadis. A galaxy over 1,600 light years in diameter and made up of very young stars. The strangest part? The galaxy formed less than 300 million years after the Big Bang and already has several hundred million times the mass of our Sun. How did it become so massive so quickly? We don't know. This galaxy calls into question our models of how galaxies form, but it doesn't call the Big Bang into question. And so, thanks to the powerful infrared eyes of the James Webb Space Telescope, we can see through cosmic dust to uncover these new mysteries. The presence of heavy elements in the Jadis galaxy, such as dust and oxygen, suggests that several generations of stars have already lived and died by 300 million years after the Big Bang. That's the mystery. How can that happen so quickly? What do you think? Have you ever wondered where life first appeared? The Panspermia theory says that the first building blocks of life appeared in space and then arrived on Earth. How do we know this is possible? From the laboratory. Scientists have recreated conditions similar to those in space in a vacuum chamber, with substances found in stellar nebulae, such as ammonia, atomic carbon, and carbon monoxide. And they discovered that these ingredients can form precursors of amino acids, which then combine to create peptides. In space, this process is not easy. Because the dust in these molecular clouds contains frozen water, the formation of peptides is slowed down but not stopped. Considering that the universe is billions of years old, there's plenty of time. And yet another example in support of panspermia. Glycine, the simplest amino acid, can form in interstellar clouds long before stars begin to shine. These molecules could travel on comets and meteorites, bringing the seeds of life to planets like Earth. Imagine that. The building blocks of life are formed in the frozen depths of space, then brought to our young planet. This could mean that some of the ingredients for life on Earth are actually extraterrestrial. Isn't it amazing? We are literally stardust. Aurora Borealis in Romania. Why are we seeing them now and not in the past? Well, the sun is approaching a maximum in its 11-year activity cycle. In fact, NASA announced a powerful solar flare that happened 3 days ago. What we're seeing here could be the result of that. On the other hand, some solar cycles are more intense, others are not. There's also the camera, which amplifies the colors and spreads the photos on the internet. Especially this red color, which is caused by the solar wind, particles like electrons and protons that hit the atmosphere at altitudes over 200 kilometers and excite oxygen atoms in the rarefied air. When the solar wind penetrates deeper into the atmosphere, you get green and then even blue light. Kind of like a rainbow. Did you see anything? This is what Hyperion looks like, one of Saturn's moons. It looks like a gigantic sponge from space. Look at this surface. It's about 200 kilometers across and is covered with strange craters like deep cavities similar to a sponge. Would you want to be there? What's behind these strange craters? Well, images captured by the Cassini spacecraft revealed something odd. An unknown reddish material. It's believed that the material is similar to the one covering another of Saturn's moons, Iapetus, but it would be hard to land on this Saturnian moon. Why? Because it tumbles chaotically in all directions as it orbits around the planet Saturn. But why does Hyperion look so strange? Probably because it is a fragment of another, much larger natural satellite of Saturn that was destroyed in a massive impact. What remains is a pile of rubble with low density and high porosity, basically a giant sponge floating in space. Have you ever seen anything like that? We live in an internet world, but people around the world see the internet differently today. When I want to travel virtually and I'm curious about how the world looks in those countries, I use a VPN. Surfrag is a VPN that gives you access to the entire movie database on Netflix and cheaper subscriptions to some platforms, YouTube Premium, HBO, and so on. Surfrag hides your IP address and thus ensures your online privacy while browsing the internet. You can search for plane tickets and hotel rooms at lower prices. This comes with a minimalist and user-friendly app design. With the Surfrag Alert service from Surfrag One, you can monitor your data, check for possible breaches, receive alerts, and benefit from real-time protection. And Surfrag Antivirus helps you keep your device virus-free. Perform a quick or full scan of your device, benefit from real-time protection, and schedule scans. Ensure your privacy with Surfrag. Go to my link in the description and you'll get 4 months free. Did you know that all life on Earth might have a common ancestor? Let me introduce you to the grandmother or grandfather of life, LUCA, the last universal common ancestor. Scientists believe that LUCA lived about 4.2 billion years ago, several million years earlier than previously thought, and only 400 million years after the Earth formed. That means LUCA lived right in the middle of Earth's Hyperion eon, a time when our planet was a chaotic world of fire and lava. LUCA would have been an organism similar to prokaryotes, which means it didn't have a nucleus. Think of it as the ancestor. Well, you get the idea. The grandmother or grandfather of every living thing today. So, how do we know that LUCA existed? Scientists compared the genes of living species and traced them back to this common ancestor. They discovered that LUCA would have had some fascinating features, such as an immune system to fight against ancient viruses. Yes, even 4.2 billion years ago, life was already in a survival game, fighting against primordial viruses. And guess what? LUCA wasn't alone. Its waste was food for other microorganisms, creating a recycling ecosystem. We're talking about teamwork. From tiny bacteria to blue whales, every living creature on Earth shares this incredible lineage. LUCA's universal genetic code, the mechanism of synthesis and protein chirality, as well as the use of ATP as an energy battery, are found in every cell today. So next time you think about life on Earth, remember this: we are all possibly connected to this ancient microscopic ancestor. Pretty amazing, isn't it? Have you ever wondered which countries consume the most fossil fuels? Here's the list from 2023. Have you ever wondered which countries consume the most fossil fuels? Here's the list from 2023. China and the United States are responsible for almost half of the world's consumption, with China ranking first with 140 exajoules, mostly from coal. For comparison, Germany uses about 9 exajoules. Where does this difference come from? On one hand, it's because of the large population. China has a population 17 times bigger than Germany. In fact, the fossil fuel consumption per capita in China is about the same as in Germany. However, in the United States, the per capita consumption is twice as high. It should be noted that both in the United States and in the European Union, fossil fuel consumption has decreased by more than 10% in the last 20 years. Meanwhile, in China and India, it has doubled, mainly due to economic growth. As we've seen, per capita consumption in China has reached about the same level as in Germany. Despite the efforts, today in the world, 81.5% of energy is produced from fossil fuels. The energy transition is happening, but fossil fuels still dominate. What do you think? Thank you for watching the video until the end, and thanks to Surfrag for sponsoring. Don't forget about my link in the description. This way you ensure your privacy with Surfrag and get 4 free months. Until next time, I am Christian Presura, Physics Explained. You are the audience and I wish you all the best. Goodbye.